Today on Signals Everywhere, we take the SA828, and with a little bit of reverse engineering and Python coding, we're able to take this typical module used for two-way radio communications and turn it into a frequency-hopping data radio. Don't go anywhere. You're watching Signals Everywhere. If you're interested in software-defined radio and radio communications in general, please be sure to press the subscribe button and hit that bell icon so you don't miss any future content. Today's video is being sponsored graciously by Eltima software. They produce a ton of really interesting products. However, the one we're going to focus on today is Serial Port Monitor. I'll be using this application to actually go through and tear apart serial communications from this particular radio module and then using that to create our frequency hopping application. Let's first take a quick look at the software. We need to set up a new session, and as you can see within the session we're able to select several different views. So we have our table view, line view, dump view, as well as terminal view. Once those are set up, we can go ahead and click the Start Monitoring button, and then we'll wait for these views to open up for us, and then from there we'll be able to go ahead and begin debugging our serial applications. Now that the Serial Port Monitor program is up and running, we can go ahead and start up the NiceRF programming software for our 2-meter radio module. We're going to go ahead and open the serial port, and you can see we already have data beginning to show up in the available views in the Serial Port Monitor. If we go ahead and zoom into our first view here, we can take a look at the data that's coming off of our serial module, as well as the data being sent from the programming software itself. So in purple you can see the command that the software is sending, and then in green is the response coming from the radio module. So here we can see all of the frequencies currently programmed into the module, and you can see that the software actually does a little heartbeat where it continually asks the module to check and see which version of the module it is looking at. An alternative way we can look at this is in the dump view. If you take a look, our first set of bits are AAFAA, and in response our module returns the version number that it happens to use. The second command we seem to be sending is AAFA1, and that returns in response from our module all of the frequencies and other settings that are currently stored within that module itself. One of the nice features of this software is that it allows you to save your session to a file and then load it up later on if you need to review it at a later date. This is great for our purposes since now we have a copy of all of the data that was sent when we read our module. Now we want to capture all the data that is sent when we write something to our module, so that way we can facilitate features like frequency hopping. Using the programming software that came with the module, I'm going to program it for 142.55 MHz, both so that I can test that it is transmitting on the correct frequency, as well as to capture all of the serial data used for programming this module, so we can jump to the next step, which is writing our own programming software so that we can instill the frequency hopping aspect to our module. The first thing we'll need to do is grab the first set of bytes that the programming software originally sent, which is AAFAA. And if you recall, when we paste this into my script here, these are the same bits that were used to retrieve the version number of our module. So let's go ahead and run that code and see what returns. And as you can see, when we run that, it is returning the same SA828 model version, or model number rather, that we saw when we ran it directly in software. And if we switch back over to the Serial Port Monitor, you can see that our output looks exactly the same as it did from the original software, which really shows us that we're on point and moving in the correct direction for sending our own custom commands to this particular module. Now it's time to take the output of our programming that we saw when we were programming our module using the original programming software and add this to our script as well. So now we're going to actually copy the exact output that we had here. We're going to paste it into the Python script. I'll make a link to the script available in the description, of course, if you're interested. And then from here, I can even change some of the values inside the programmer before we run it. And if you see here, it is now successfully updated the programming within the module. We can then switch over to a program like SDR # just to confirm that it is indeed transmitting on the new frequency that I've chosen. Now, as a proof of concept, I should be able to do some quick modifications to the code here and place it inside of a while loop. By doing this, I can generate some random numbers for the frequency before and after the decimal, and then reprogram the radio module repeatedly, When I run this in a loop, it will then continue to change the frequency of the module rapidly every few seconds. So every time I key this module up, it'll be transmitting on an entirely new frequency. Now, of course, you're going to want to have two of these radios that are constantly hopping to the same frequency at the same time, but for general proof of concept, I went ahead and just made this one completely random. Eltima's serial port monitor is a very interesting and extremely useful piece of software. I've actually used it in the past before to modify things like amateur radio transceivers that did not support the frequency range that I wanted to enter into them. And it does so by allowing you to, of course, view and reverse any serial communications you see. One of the ways it does this is with its multiple view modes. Now, this particular mode in particular is the terminal view, and you can see it shows both read and write data in the same window. So purple data is data that we've written, where green data is data that we've received off of our serial port. Eltima's serial port monitor also provides us with something called line view. Line view, of course, is going to show you data as well, but this is actually more suited toward giving you the exact status of your serial port. Is an open being requested? Is a close being requested? Things of that nature, and it provides you some more debugging details that you wouldn't be able to receive in something like the terminal view. Next, we have what's known as the table view, and the table view, much similar to what we saw in the line view, is it's going to provide you a lot more diagnostic information about the status and the functions that are actually being performed by your serial port, in addition to the data in multiple formats that's being sent as well. So you can see the data in both ASCII as well as in hex in this view, in addition to the serial port states. And then finally, we have one of my favorite views. This is known as our dump view, and this is the one I use the most. So we can see it's all time-stamped. We know that we're opening a serial port and what application opened it. We can see the data that was written and what COM port it was written to, data that was read, and then it goes back and forth. And of course, we can do things like search for data within this particular stream of serial communications, as well as do things like copy and paste it out to our Python application. So a real handy piece of software without a doubt.